With a no crank problem without any noise, you could have a dead battery, open connection, bad solenoid, or a bad starter. Slow cranking is usually caused by similar troubles. A buzzing or clicking sound from the solenoid may be due to a dead battery, poor cable connection, or bad solenoid. A humming sound after cranking may be due to a bad starter clutch or worn pinion gear. The humming noise is caused by the starter spinning without a load. A grinding sound may be caused by broken flywheel teeth or worn pinion gear teeth. If the engine starts and then dies as the ignition key is released, check the ignition switch and solenoid feed to the ignition coil. These are the most common problems you'll find with the starting system. Always perform a visual inspection of the battery and related components before doing starting system tests. Does the vehicle have the proper battery? The capacity of the battery must meet the minimum requirements stated by the manufacturer. Check for physical damage to the battery. A cracked case, cracked cell cover, or sealing compound defect would all require battery replacement. Check for loose side or top terminals. When a post is loose in the battery should be replaced. Stripped side terminal or terminal bolt threads should be corrected. Acid or dirt on top of the battery should be washed off to prevent any possible current drain. If you touch a voltmeter to the top of the dirty battery, it will show a voltage reading. The constant current drain will reduce battery life. As you can see, the voltmeter reads over 5 volts. Also, make sure that the battery hold down is secure. If the battery is loose in the engine compartment, physical damage can result. A common fault is corroded battery terminals. Service them before performing any battery and starting system tests. A poor electrical connection will prevent accurate testing. Use a battery terminal tool to clean the post and cable ends. Since most batteries have non-removable vent caps preventing the use of a hydrometer, the open circuit voltage is the most common method for checking battery state of charge. For 12-volt batteries, 12.4 volts or higher indicates a satisfactory charge. Charge the battery if needed. It is impossible to test the battery and charging system with a weak battery. Use manufacturer's instructions and a load tester to load your battery to the prescribed amount of current. Read the voltmeter as amps are applied. If voltage drops below specs, the battery is faulty and should be replaced. Battery current specifications are normally given on top of the battery. The first test of a starting system usually involves measuring current draw with a load tester. Your load tester will measure the cranking current sent to the starting motor from the battery when the engine is cranked. Disable the ignition or fuel system to prevent the engine from starting during the cranking test. Here, we are pulling the fuse to disable the fuel pump and prevent the engine from starting. With some engines, you can remove the coil wire and the battery feed to the ignition system to disable the engine and prevent starting. A remote starter switch is handy when the solenoid is mounted in the engine compartment. Connect the switch across battery voltage and to the start terminal on the solenoid. By pressing the tester button, you will crank the engine and do not have to sit in the car and turn the key to test the starting system. Use your load tester to measure starting system current draw. To prevent starter damage, don't crank the engine for more than 15 seconds and allow it to cool between tests. Typical starter specs are as follows. For a 4-cylinder gas engine, 120 to 200 amps. With a reduction starter, 150 to 250 amps. 4-cylinder diesel, 350 amps. 6-cylinder gas, 250 amps. 6-cylinder diesel, 450 amps. 8-cylinder gas, 250 amps. 8-cylinder diesel, up to 650 amps. Again, refer to factory specs because they are more accurate. Here are some common starting system problems. A burned contact in the solenoid will prevent cranking and will show up as a low current draw. Replacing the solenoid will sometimes salvage the starting motor. Worn brushes can show up as abnormal current draw. Starter motor replacement would be required. One reason for an excessively high current draw during cranking would be shorted windings on the starting motor. This too would require starter motor replacement. In general, remember that a high current draw is due to low circuit resistance. Normally, the problem would be in the starter motor. However, don't rule out an engine mechanical problem that is increasing load and current draw. A low current draw would be due to a high current resistance, as from a poor electrical connection. Also, check for problems like loose starter mounting bolts, which could affect gear engagement and current draw. Voltage drop tests can quickly locate a part with higher than normal resistance. They provide an easy way of checking circuit condition. You do not have to disconnect wires or components to check internal resistance or voltage drops. Crank the engine with the voltmeter connected to the section of the circuit to be analyzed. Generally, you do not want over about a 0.1 to 0.2 volt drop across any electrical connection. For example, if you connect the voltmeter from the battery to the starter input terminal, you will check all connections between the two test points. Your voltmeter should show only about a 0.5 volt drop with the engine cranking. A higher voltage drop would show a poor electrical connection. You would simply move your test leads inward to isolate and find the source of the high resistance problem. Before removing the starter motor, always disconnect the battery. Then, if you accidentally touch the starter cable to ground, it will not short the battery and blow the fusible link or burn up wiring. It will also prevent accidentally cranking the engine while working near the ring gear. To remove the starter motor, first remove the bolts holding it to the engine. Support the weight of the motor when removing the last bolt. If the solenoid is on the starter, disconnect the cable and wires on the solenoid. Remove the large starter cable first and any smaller solenoid wires. Do not let the weight of the motor hang from the smaller solenoid wires or damage will result. Hold up the starter motor when you remove the smaller wires coming from the ignition switch. Reinstall a new starter motor in reverse order. The solenoid, since it must switch hundreds of amps, is one of the most common parts to fail. Replacing the solenoid can often return a starter motor to normal operation. Screws normally hold the solenoid on the starter motor. After removing the screws, rotating the solenoid will free it from the motor. Always check the action of the lever and plunger during service. Make sure parts are not worn and that they move freely. A frequent reason for high resistance in the solenoid is a loose locking nut. The outer nut holding the wire can be tight, but the inner nut on the terminal stud can be loose. This can prevent normal current flow through the circuit. If the solenoid clicks once, but the starter does not energize, the high current disc or contact could be burned. This is a common problem. These same troubles apply to remote-type solenoids in the engine compartment. Besides your voltage drop test, an ohm meter will verify a burned solenoid contact. Push up on the inside of the solenoid while measuring the resistance across the two large cable terminals. A high resistance verifies a burned contact. Install a new solenoid in the reverse order of removal. Then bench test the starter before reinstallation by using jumper cables and a battery to energize the solenoid and motor to verify the repair. A misadjusted or bad neutral safety switch could keep the engine from cranking when the key is turned to start. You may have to wiggle the gear shift to get the engine to crank or place the shifter in neutral. Most neutral safety switches are adjustable. With the transmission gear shift set in park, loosen the bolts on the switch. With the key held to start, rotate the switch until the engine cranks. As soon as the engine cranks, tighten down the bolts that secure the neutral safety switch. Then recheck the adjustment by moving the shift lever into park, neutral, and the various gear positions while starting the engine. A faulty ignition switch can also prevent engine cranking. The ignition switch may not be feeding current to the starter solenoid. A test light will quickly tell you if current is being fed to the solenoid whenever the key is turned to start. To replace a modern column-mounted ignition switch, remove the plastic steering column covers to gain access to the switch. In some cases, the steering wheel must also be removed to completely remove the plastic covers. Use tamper-proof Torx to loosen the retaining screws. Replace the switch and tighten the screws. Reassemble the plastic covers in reverse order. To replace an older column-mounted ignition switch, a small hole must line up with the pin or rod leading from the ignition key mechanism. Fit the rod into the hole, then reinstall the fasteners that secure the ignition switch to the steering column. Slotted holes in the ignition switch allow you to adjust the switch. Hold the key to start, then slide the ignition switch until the engine cranks, then tighten down the screws. Fusible links are often used in a starting system. If you forgot to disconnect the battery, they protect against serious electrical damage if you accidentally short a hot wire to ground. A fusible link is basically a large gauge wire with a small gauge wire linked in the middle. The small gauge wire will overheat and burn if you accidentally short the wire to ground. The short will produce excess current flow, which heats the link and burns it in half. When the link burns in half, it protects the rest of the car's wiring from major damage. On today's systems, a large high-current fuse is often wired into the charging system. A major short can blow the fuse. Check for a blown fuse or a fusible link if power is not reaching major sections of the car's electrical system.